All right, we are going to introduce to you today matrices. First, we're going to define what a matrix is. A matrix is a rectangular array of variables or constants in rows or columns, usually enclosed in brackets. Just as a visual example of what that is, a matrix might look like A equals, and then in brackets, maybe we have a row where we've got -3, 6, 24, and in another row we've got 0, -15, and -7. And then I've got a couple elements, if you will, about matrices. Or we're going to define what elements are and how they can be identified in a matrix. So first, elements are the individual values within the matrix. We also say that element A with a subtext X and Y is used to denote each element where X is the row number and Y is the column number. Where the element is located in the matrix. So, that actually brings me to my first example. We're going to look at the following matrix, matrix A, which has 3 rows and 5 columns. The first row has the numbers -8, 40, 0, -1, and 21. The second row has 27, 32, -29, 6, -2, and the last row has 5, -17, 14, 52, and -35. We're going to identify different elements of this matrix. So the first element we're going to identify is A25. So we're going to look in the second row, that's what the 2 means, at the 5th element. So second row, 5th element, row 2, element 5, gets us to -2. And then we're done with that part. The second element we're going to look for is A31. That's third row. First element, third row. First element is going to be 5, right here. The third element we're going to look for is A12. That's the first row, second element. That's 40. We're just going to finish filling in the questions we have on our note sheet. A34, that's third row, fourth element, that's 52. We're going to look at A15, that's first row, fifth element, That's 21. And then the last one we're going to look at before moving on, A22. That's second row, second element. That's going to be 32. Now a matrix is going to have dimensions. So let's define what dimensions are for a matrix. A matrix with m rows and n columns is said to be an m by n matrix. So we write that as like m times n matrix. So I've got a few here where what we're going to do is, given the matrix, we're just going to state the dimensions. So I've got the matrix -5, 34, -18. So I see we've got one row, so that's our m, and we've got 3 columns, that's our n. So this matrix is a 1 by 3 matrix. We've got 3 more matrices to look at. We've got the matrix that looks like the following. I see 4 rows and 2 columns. So that means this matrix is a 4 by 2 matrix. Let's look at the last two. Next one and then one more. So we've got the following matrix: -11, 37, 4, -2, 0, 9, -5, -3, -16, 1, 25, and 12. I see 3 rows and 4 columns. So this is a 3 by 4 matrix. So let's look at one last matrix before we look at the next topic of the day. So we've got the following matrix: 7, -3, 0, -23, -1, and 5. And then we've got -31, 10, -6, -14, 18, and -26. So I see 2 rows and I see 6 columns. So this is a 2 by 6 matrix. Alright, let's take a look at what our next topic of the day is. We're looking at equal matrices. We define equal matrices as 2 matrices in which each element in one matrix is equal to the corresponding element in the other matrix. I've also got 4 special matrices to show you. We're going to start by just writing the word, and then I'll draw what they look like. So we've got a row matrix, a column matrix, we have a square matrix, and a zero matrix. So a row matrix, it's pretty simple. All it is, it's a single row. It might look like it's got some elements in it, and it's a row. Column matrix, also pretty self-explanatory. It's going to have some elements, but they are in just a single column. A square matrix is going to be a matrix that has the same amount of rows as it does columns. And then a zero matrix is going to be a matrix where all the elements are 0. Now, we can do some basic operations with matrices. We can do addition and subtraction. In fact, matrices can be added or subtracted if and only if they have the same dimensions. And to do that, we are just going to simply add or subtract corresponding elements. So I've got a few examples to look at. First, what we're going to do is define some matrices. We're going to define matrix W as follows. It's got a row -1, 9, another row -11, 15, and a third row 8, -20. We're going to define another matrix, X. It's a 2 by 3 matrix. The first row has 24, -8, -3. The second row has -4, 6, -17. We've got another 2 by 3 matrix with Y. The first row has the elements -15, 29, and 17. The third row has elements 9, -5, and -2. And lastly, we have Z, which is a 3 by 2 matrix, just like W. It's got the elements -3, -2, -16, 0, and 12, 9. Now our first example here is question 11 on our note sheet. We're going to add matrix X and Y. As long as the dimensions are the same, exactly the same, we can do the addition. X and Y are both 3 by 2 matrices, so we can add them. So when we're doing that, we're going to result in another 3 by 2 matrix. We're going to take 24 and we're going to add to it -15. We're going to add the corresponding elements. We're going to take -8 and add 29. We're going to take -3 and add 17. And then we're going to move into the second row. We're going to take -4, add 9, take 6, add -5, take -17, and add -2. Now we're just going to simply do the addition. 24 plus -15, that's 9. -8 plus 29 is 21. -3 plus 17 is 14. So we've got the first row done. If we go -4 plus 9, that's 5. If we go 6 plus -5, that's 1. -17 plus -2, that's -19. And we finished the matrix addition. We're going to keep utilizing these same matrices, but I need more space to keep moving on. In question 12, we're going to take Z and subtract W from that. So, Z and W are both 3 by 2 matrices, so we're going to just subtract. We're going to go the first element, first row of Z is negative 3. We're going to subtract negative 1 from it because that's the first element in the first row of W. So then we're going to go negative 2 minus 9, and we're going to move down another row. We've got negative 16 minus negative 11, and 0 minus 15. Move down one more row. We've got 12 minus 8, and 9 minus negative 20. Now, as a reminder, when we minus a negative, that's just the same as adding. So if we have that doubled up, we can go and change any minus negatives to adding. So now we combine them. Negative 3 plus 1, that's negative 2. Negative 2 minus 9, negative 11. Negative 16 plus 11, negative 7. 0 minus 15 is negative 15. 12 minus 8 is 4. And 9 plus 20 is 29. We do need to make sure that when we are doing this matrix subtraction, if Z happens first, Z's elements go first. Because we know that 8 minus 12 is very different from 12 minus 8. So now let's look at 13. We're going to go W plus X. Well, W is a 3 by 2 matrix. X is a 3 by 2. We can't do that. W plus X is not possible. Let's also look at 14. 14, we're taking X and we're subtracting Y from it. They're both 2 by 3 matrices. We can do it. So we're going to take the first element in the first row of X, that's 24, and subtract negative 15. So we can make that 24 plus 15. We're going to go negative 8 minus 29, negative 3 minus 17. We're going to go negative 4 minus 9, 6 minus negative 5, so 6 plus 5. And we're going to go negative 17 minus negative 2, so plus 2. Now we can combine them. So we're going to get, when we do our combining, 24 plus 15 is 39. Negative 8 minus 29 is negative 37. Negative 3 minus 17 is negative 20. We move down a row. Negative 4 minus 9 is negative 13. 6 plus 5 is 11. And negative 17 plus 2 is negative 15. So we are done with that matrix operation. There is one more topic we need to cover before we're done with this lesson, and that's scalar multiplication, but we're going to talk about that in our second video.